So we have non-point source pollution and point source pollution. And kind of like the name implies, you see the pollution, but you can't point to the source. And there's a lot of reasons why for that. But the major culprit as to why we have non-point source pollution is something called impervious surface. Now let me be really straightforward with you. Non-point source pollution comes from a variety of things. It's just impervious surface is kind of the big one. Impervious surfaces are surfaces that do not let water go through it. Water cannot reach the ground. And I think this is best explained with examples. So here we have an aerial photograph of the college campus, and we see a variety of both impervious, those that don't let water through, and pervious, those that do let water through. Let's talk about pervious first. If it rains on this field, that rain is going to hit the grass, it's going to hit the soil, and it's going to soak into the ground. If it hits the forest, same thing. If it hits the lake, same thing. But with impervious surface, like this parking lot, it hits that parking lot, it hits that asphalt, and the water has nowhere to go. The water does not go through the asphalt. It runs off. Water hits the top of this building, but it doesn't go through. It runs off. It doesn't permeate or go through concrete sidewalks. It runs off. And this is where this non-point source pollution is starting. Because when that water runs off of these surfaces, it's going to bring stuff with it. Now, sure, we have impervious surface. But what does that have to do with pollution? And what does that have to do with pollution in nature, right? Okay, there might be trash on the road, but why does this matter, or how does it even get into our environment? Now, we as society recognized the problem with impervious surface pretty early on. We realized that by making these impervious surfaces, when it rained, we started having flooding. Right? If you have a huge roadway system or a huge parking lot or a really large building, and you have all this water that needs to go somewhere, it's going to go somewhere, but it's a lot more water, and we started having flooding. So society created this system of stormwater drains, and you have seen these. You have seen tons of these, maybe not even realizing what it was. So here's a picture of an example of one. So when it rains, water goes down a stormwater drain. And as the name implies, a stormwater drain is a series of pipes that's going to take stormwater or rainwater, or really any water that is running off this impervious surface, and it's going to take it to a series of drains and to a series of pipes that eventually is going to lead into the environment. Now, this is different from a sewer system. So stormwater system is collecting water that is running off the roads and parking lots. A sewer system is what's running from your home. This is what's running from the bathrooms in a building. That has human waste that goes to get treated. Stormwater drains do not get treated. Stormwater drains just collect everything that was running off those surfaces, and then it'll go directly into the environment. The diagram that popped up kind of shows this. So if we think about our water cycle, we bring water in from a local body of water. We clean that water before sending it to our homes. From our homes, it goes down the sink drain, it comes out of the washing machine, goes to a wastewater treatment system to get clean before entering the environment. However, our stormwater drain, so here we have water rushing off of someone's driveway, it might be carrying motor oil, pesticides, pet waste, and it drains into a stormwater drain that does not get cleaned and goes directly into our environment. Now, I do want to make a caveat real quick, because you might see something like this in nature. You see a lake, you see a pipe, you see pollution coming out of that pipe, and you may be tempted to be like, that looks like point source pollution. But remember, point source pollution means that you know exactly who created that pollution. But when it's a stormwater drain, like the one we see actually in this picture, and a McDonald's cup comes from it, or oil from a parking lot comes from it, sure, it's pollution. Sure, it's coming out of a pipe, but I don't know who made that. I don't know whose car that oil came from. So again, I just wanted to do this aside because when we talk about stormwater drains, it can be easy to think of them as point source pollution, but they're not. That pollution in that water comes from so many sources, and we have no idea who it comes from. There's no way of narrowing down who the actual source is of that pollution. Now you might be thinking, well, okay, but like, why don't we clean it? Why not? And we'll talk about that more when we talk about solutions. But because it's not cleaned, and because it's just a system that goes directly into the environment, it's barely regulated. You know, the Clean Water Act does a really great job in regulating point source pollution. But non-point source pollution, I mean, honestly, the biggest producers of non-point source pollution is us. Like, we're the ones dropping stuff onto the streets. We're the ones littering. It's not Coca-Cola who's like, I'm throwing in my bottles everywhere. No, it's you and me driving our vehicles, living in our homes, parking in parking lots. It's us. We're the producers of non-point source pollution. And while, yes, there might be local littering laws, I mean, think about it. Have you ever heard of someone getting a ticket for littering? Maybe you have, but it's really rare, right? You hear more about speeding tickets than you do littering tickets. It's really hard to regulate it because it's so pervasive. There's so many people doing it. It's not a big company producing all of this pollution. No, it's you and me doing small actions. And, you know, again, look at this oil in this parking lot. I have no idea whose car that came from. Even if I wanted to give a ticket to someone who was leaking oil, I couldn't even do that. I don't even know where to begin. I can't identify whose car it is. So that's the unfortunate thing, is that this is a pretty pervasive problem. It's a really hard one to fix. There's really not laws in place to address it because those laws are pretty much impossible to make. Let's talk about some of the impacts, some of which we've already talked about. So we have this impervious surface. We know is contributing to non-point source pollution because those pollutants, whatever that pollutant is, it can be litter, it can be chemicals, it can just be things that shouldn't be in nature, very easily run off. Imagine something in your driveway and it rains. Well, that water doesn't go through your driveway, doesn't get soaked in by the ground. Instead, it runs off of your driveway and it's going to carry stuff with it. It's going to carry that ketchup packet that you maybe thought you threw away, but you didn't. Or let's say you wash your car in the driveway. All that soap and car grossness goes down your driveway, into the street, into the gutter, into a storm drain. So it's really easy for pollutants to run off and eventually enter our local waterways, like you see in these pictures. I'm not really going to focus more on this because we've actually talked about this a lot. But there's more impacts to impervious surface other than just pollution. And if you're looking at this picture, you're like, is it eggs? Egg pollution is not a problem, you guys. Hopefully, by this picture, you have identified what I'm trying to tell you. Think about, especially here in Maryland, a hot summer, humid day, crazy hot in the morning, and then we typically get a thunderstorm in the afternoon. And that water comes down onto that really hot black asphalt. And after that storm, you literally see steam coming off because that asphalt is so hot. Well, that rainwater just hit that asphalt. That rainwater just got warmed up. That rainwater that's now a whole lot warmer because of the asphalt that it's running across is now entering the environment a whole lot warmer than the water that exists in that environment. This is a type of pollution. It's a type of pollution called thermal pollution. Thermal referring to temperature. So while, let's just say that road is pristine, there's not a single chemical, there's not a single piece of trash, but it just warmed that water 20 degrees warmer than the environment it's going into. For some organisms, not a big deal. It's fine. For other organisms, big deal. We're talking death to organisms, even death to organisms that we care about, like trout, like carp, like bass. Things that we catch and consume, or things that we catch for leisure, are now at risk because of this impervious surface, because of this thermal pollution. Another impact of impervious surface is demonstrated by this graph. I'm going to outline the graph and I'm going to pause to give you a moment to think about it. So on the x-axis, we're looking at time, and this is in days. So for example, the 30 on the left-hand side of the x-axis, this is January 30th, year 2000. And then the 31st, February 1st, February 2nd, etc. On the y-axis is water discharge. Honestly, just think of this as volume of water. Don't worry too much about the unit. So how much water is going? And what we're looking at is two different creeks. We're looking in blue at the Newaukum Creek and in green, Mercer Creek. And so what we're doing is we're following the amount of water that is being released into these streams. And specifically, we're focusing on a storm that happened late on January 31st. And what we're looking at is how much water is in each of these creeks. Now on the right-hand side, I have a couple of questions going on, asking you about this graph. What could you tell me about the ecosystems surrounding this graph? And potentially what kind of damage might we see? So I'm going to pause here for a little bit. Honestly, for only a couple seconds. I actually encourage you to pause this video. So go ahead and pause this video in 3, 2, 1. Well, I hope you had a chance to actually think about this and that you weren't just like, I'm going to just keep moving on in this video and she's going to tell me the answers. Because you will know that I will tell you the answers, but it's more helpful for you to try it on your own first. So if you're like, maybe I will try it on my own first, then I encourage you to pause now. Okay. All right. You're here. So you may have noticed that the discharge is very different between these two ecosystems after the storm. In the green Mercer Creek, they have so much water coming through. Maybe, thinking about question 3, we might be having issues with flooding. We might be having issues with erosion, and we'll talk more about that soon. But why? I mean, Mercer Creek and Newaukum Creek, I didn't tell you this before, but they're actually right near each other. Like, it's not like, Newaukum Creek is on they're on the clear other side of the state. Like, no, they're like pretty close to each other. But despite being close to each other and despite experiencing the same storm, we have very different discharges. So hopefully, thinking about what we're talking about, you may have made the connection that, maybe Newaukum Creek, the one in blue, the one that has less discharge, maybe this is in a more pristine location, in a more pervious location. There is soil, there is grasses, there is trees, there's bushes, there is things that will absorb that water and take in that water. Whereas Mercer Creek, it's a lot more suburban. It's a lot more urbanized. There's a lot more impervious surface. That water is hitting concrete. It's hitting asphalt. It's going into a stormwater drain and going directly into the environment with no opportunity to get absorbed at all. So we see much, much, much higher discharges. Let's talk about those higher discharges because that can be problematic in and of itself. All that water going through the environment can cause things like flooding and high water flow. It can also cause things like you see in the picture on the right-hand side, like erosion. If water is rising up and it's moving really, really fast, it's going to take soil with it. It's going to erode or tear away at the banks of this ecosystem. Now, maybe you're like, I don't care. I hope you care, but maybe you don't. If you look in this background, we see a bridge down the way of the river. So if you have a whole lot of flooding, you're going to have a problem with your infrastructure. We also see someone's back fence. So if you have a whole lot of erosion and a whole lot of flooding, either one of them, you're going to start having impact to properties. And so this can have a really real economic impact by having such a high flow from a very large stormwater drain network. Something else, this was a cool image I found just to put some numbers or scale with it. That if you compare the same amount of rain into an urbanized and a forested habitat, that while you'll still have runoff in a forested habitat, we're looking at 1,300 gallons versus 25,000 gallons. So a huge scale in difference between these different types of surfaces and their impact to runoff. So again, non-point source pollution can happen on a variety of surfaces. It doesn't have to be just in impervious surfaces, but I will say a vast majority of the pollution that you're seeing in this picture is coming from rain events where litter, where chemicals are being washed away on surfaces. That's most likely to happen on impervious surfaces because water doesn't even get a chance to hit the ground. It just gets carried along on concrete, on asphalt, on buildings, etc. I know it sounds like doom and gloom, but don't worry, we do have some solutions to this. And those solutions are going to be pretty important because remember, you and I, we're the cause of this non-point source pollution. This is not a chemical and industrial company problem. This is a human society problem.